All right, guys. So these notes would be over even and odd functions. Before I get started, make sure you post your notes on Microsoft Teams. It does not have to be a notebook like this. It can be a spiral. It can be a binder or paper that you're keeping in a folder. When you open it up, the first page is going to be the table of contents. So these are the first set of notes we're going to be taking. And I will skip about a couple of pages before we start taking notes. So a good way to keep track of your notes and the title of them is by going by weeks. So you can go right week 27, lesson 1, and today's date is 3/31/20. So this whole lesson will be over polynomial graphs. So before we start talking about even and odd and their graphs, we first need to talk about the parts of a polynomial. So parts of a polynomial. So let's take this polynomial, for example. We have 3x to the 4 plus 5x to the 3 plus 7x squared plus 9x plus 10. Whew, long polynomial here. So there are different parts of a polynomial that make it really important. The first, what we're going to talk about is called the leading degree. So the leading degree is the highest exponent. So I'm just going to write here, leading degree is the highest exponent. Is the right. So this polynomial will be of degree 4. The number in front of the leading degree, we call that the leading coefficient. So this is the leading coefficient. Leading coefficient. All right, so all these parts in between are called terms. All these parts in between are called terms. And terms are separated by either a plus or minus sign or operator. So this is a term, this is a term, this is a term, this is a term, and even 10 over here is a term. These are all terms. All right, so the last part is this number at the back. This is called a constant because it does not have an x. So constants don't have a variable. All right, so now we know the different parts of a polynomial. So now let's get into even and odd. So I'm going to turn the page because these notes are going to take the entire page. So we're going to have even versus odd. Now turn your notes to the side because the way I'm going to write these notes out is going to be easier for us to keep track of them. So let's put odd at the bottom. And we have even. All right, so we got odd and even. Now, turn your page back over like this and split it down the middle. Oops, I tore my page. Split it down the middle. All right, so first, let's talk about even functions. So let's say I have a positive leading coefficient. So I'm going to put my leading coefficient. Positive a to the x to the power of some exponent n. Okay? So I know it's even, right, if n is an even number. Pretty simple. Now, if it's positive, if my leading coefficient is positive, my graph will look something like this. Now, we don't care about what's going on in between. But if it's even and it's positive, the graph will be going, let me do it in a different color. Let me do it in, it'll be going up and up. Now, I don't care about what happens in between, all right? I just know it's going to start in the up, pointing up, and it's going to end pointing up. Let's talk about if it is negative. So let's say I have a negative ax to the power of n. We're still even, so that means n is still an even number. But my leading coefficient is negative. So my graph will be in the down position. It will start down and end down. So something you need to know about even functions is that my arrows are going in the same direction. Same direction. They start and end in the same direction. And if it's positive, it will be up and up. If it's negative, then it will be down. So far, so good. Hopefully I haven't lost anybody yet. Now let's talk about odd. So if I have an odd polynomial, I know it's odd if my n is odd. So let's put this one in green. So if n has to be an odd number. Now, odd functions, their graphs are going to look a little different. So if I have a positive leading coefficient, my a is positive, the graph will start down, right? But it would end pointing up. Oh, let me scoot it up. Y'all didn't tell me y'all couldn't see. This is for odd functions. It will start down and end up. Let's say I had a positive leading coefficient. So I have positive ax to n. And we know that n is odd, so n is going to be an odd number. And let's see what the graph will look like. So the graph will be opposite. So it will start up, right? But it will end down. So odd functions are going in different directions. I wish this was directions. All right. So these is it. These are all the notes for even and odd functions. And we'll do some examples together later. All right, so now we're going to talk about something called end behaviors. All right, so end behavior, basically, all it does is describe the behavior at the ends of the axes, And I'm going to show you what that means once I draw the picture. So let's just draw a graph. And this is going to help you out. Let's draw a basic axes, right? And we know that this one going up and down is our y-axis. And the one that's going left to right is the x-axis. Now, when they talk about the ends, right? When they're talking about the ends, They're talking about literally the end of the axis. So let's do x, right? So let's say I was going in this direction forever and ever. What would be the end? The end would be positive infinity because it's going in the positive direction. If I was going in the negative direction, the end on my x-axis would be negative infinity. So this would be left, this would be right. Let's say I was going up. My y-axis, this would be positive infinity. And if I was going down, this would be negative infinity. So what does that mean? Well, the best way I'll be able to show you how to determine end behaviors is through some examples. So let's do an example number 1. And let's say I have this graph that looks like this. And let's see, it starts down here, and I do something crazy and like this. All right, so they want to know. So I'm going to draw my lines. I know this is positive infinity for the x. This is negative infinity. And if I'm going up, this would be positive infinity on my y-axis, and this would be negative infinity. So a question would be, as x goes to negative infinity, what is happening to y? Right? We want to know what this is. So let me write this in words. As x reaches negative infinity, y will reach. And so then we're going to look at our graph. So as x is going this way, which way is the graph going? It's going down. So we're going to put negative infinity. And let's say we have as x reaches positive infinity, y will reach oops, sorry guys. Alright, so as x reaches positive infinity, so as x goes to or reaches positive infinity, y will go to, so as I'm going to the positive infinity side, what is happening to y? Oops. As I'm going to the positive side, what is happening to y? It's going up. So I'm going to write positive infinity. Alright, so in the next video, I'm going to do some practice problems going over even and odd.